Hey, this is Leach with Simpson Math, and we are continuing to look at how to factor trinomials. In this video, we are factoring some special cases with predictable patterns that don't use the AC method. So let's get started. Now I know I just said that don't use the AC method, but let's actually use the AC method. So if I look at this x squared minus 9, let's factor it using the AC method. Well, you might be like, Mr. Leach, we're missing a number. Okay, fine. X squared plus 0x minus 9. Feel better? So go through this process. It's in order. GCF is 1. A is 1. The A is 1 and C is negative 9. You could jump straight to the answers once we get our factors over here. So what multiplies to be negative 9 but adds to be 0? Well, that's a positive 3 and a negative 3. I'm going to go ahead and show the steps. I know I just had in the last video how you can jump, but yeah. So just trust me. So let me do these steps. So we're going to replace 0x with 3x minus x. That works. Then factor out the GCF of the first two, just an x. GCF of the second two, a negative 3. And what's left inside? I have an x plus 3. What do these next two have in common? X plus 3. Yep. What's left inside? An x minus 3. So I'm left with x plus 3, x minus 3. Yes, I could have jumped a positive 3 and a negative 3. All right, so what about over this one? So 4x squared plus 0x minus 25. Same process. AC is negative 100. That's going to be a positive 10, negative 10, so that way it adds to 0. When you get done, you end up with 2x plus 5 and 2x minus 5. Notice that both of these add the same numbers, same variables and numbers, just with different signs. We call these pairs of binomials that are the same values, just with a different sign in the middle, one positive, one negative, one plus, one minus. They are conjugates. They are conjugates of each other. So also some other interesting patterns. Notice 1, 9, 4, 25. All those are perfect squares. Heck, even the x squareds are perfect squares. So we have two perfect squares separated by minus, and we end up with these conjugates where, notice, this is 4x squared. What's the square root of 4x squared? 2x. What's the square root of 25? 5. What's the square root of x squared? X. What's the square root of 9? 3. All right, so there's a really interesting pattern here, and it's called the difference of two squares. So if you ever see a perfect square minus another perfect square, you can immediately just use this formula, immediately jump to a different kind of jump, but immediately jump to this formula, a plus b, a minus b. So from the two that I just showed you, here's how to apply that formula without having to go through all the AC method. So this is a squared is x squared. So that means that a is just x. So I can replace the a's right here with x. And this is a 9 squared. So b squared is 9. Oh, that should just be a 9, shouldn't it? Yep. Let me fix that. There we go. Fixed. Silly me. So our b squared is 9. So then we end up with b equaling 3. So I can just replace the b's with 3's. And notice we have one positive and one negative just from the formula. So you can treat this just like a formula. Now it becomes a little bit more complicated over here. So all of this is a squared. So if a squared is 4x squared, what's just a? Well, square root the 4x squared. Square root of 4 is 2. Square root of x squared is x. So just write the 2x in the a spot. Same thing with this. 25 is b squared, so square root of that is 5. Put the 5 in the b spots. 2x plus 5, 2x minus 5. Let's do two that you haven't seen. So if I look at this first one, do notice, you're like, well, 3, 108, those aren't perfect squares. You're right, they're not. But don't forget about GCFs. So you have to still factor out GCFs. GCF is the first step for all factoring. So factor out the GCF of 3, and now I have x squared minus 36. Ah, yes. X squared is just x, and 36 squared is just 6. So we have the 3, because that's GCF follows us down, and there's just x plus 6, x minus 6. That's straightforward. And all I'm doing is just plugging the x and the 6 into the formula. All right, one more. And so, again, I'm recognizing that this is, I see a 9 and x squared minus 64y squared. 9 is a perfect square, x squared is a perfect square, 64 is a perfect square, y is a perfect square, separated by a minus. I know it's a difference of two squares. Once I recognize that, I'm instantly going to then just factor it. So if I square the 9 and the x squared, I get 3x. Sorry, square root. I think I kind of blurred my speech there. Square root the 9 and the x squared, and we get a 3x. Square root the 64 and the y squared, and we get 8y. So 3x plus 8y, 3x minus 8y. When I do it, I will put the plus first. But if you said 3x minus 8y times 3x plus 8y, it's the same thing. All right, but I often will do the plus first. All right, so there's a difference of two squares. There is no sum of two squares. You'll see that on your homework. You'll explore that. But there is a difference of two cubes and a sum of two cubes. Here's the formula for them. In your homework, you're actually going to investigate this a little bit more and see why this happens. But we're just going to say, here's the formula. Let's use it. Now, there's a little bit of a mnemonic that I've given you about how to remember this. So I have an a cubed minus b cubed. First, before I talk about this, let's talk about what's similar. So I have a binomial with an a, some adding or subtracting, and then a b. So a and then a b. And then I have a trinomial of a squared, then ab, then b squared. So whether it's a sum or a difference, they're the same thing. A binomial of a and then b, and then a trinomial of a squared, one of each, and then b squared. Now what about the signs, SIG and S's? So with those, let's talk about the difference first. We're going to use the mnemonic SOAP. S stands for same sign, O stands for opposite sign, and AP stands for always positive. Just a little mnemonic to help you remember. So this is a difference, and it's the same sign. So the first addition subtraction is there's 3 addition subtractions that we come across. The first addition subtraction is going to be the same as your difference or sum. The second one is going to be opposite. So notice this is minus, now it's plus. And then the third one is, well, you guessed it, always positive, so it's a plus. Going down here on the cubes, on the sum of cubes, it's a plus, so it's the same sign. Then the second sign is opposite, so it's a minus, and then always positive. So let's use this formula for 2 examples. So I'm looking at the difference here. So this is x cubed minus y cubed. So x cubed, y cubed, perfect cubes, and separated by a minus. On the products and sums page, there is a section where I want you to fill out what the cubes are, so you can recognize some of the perfect cubes. You should be good with perfect squares, so use this to find the perfect cubes and be familiar with them. But these don't have numbers on them, so you just have the variables. Those are obviously perfect cubes. So if I cube root x cubed, I'm left with just x. And if I cube root y cubed, I'm left with just b. So using this a equals x, I can replace the a's with the x's. And then using the y, I can replace the b's with the y's. It's as simple as that. Just treat it as a formula. So when I do, I get x minus y, and again, same sign. Then x squared, xy, and y squared, put the signs in. It's the opposite of the minus, and then always positive. One note, this trinomial cannot be factored. You can try, put in any numbers you like, doesn't matter, it will not be factorable. If you put in any integers into this form and try to do the AC method, you will not find a pair of numbers that works, that satisfies it for you to be able to factor. So can't do that. All right, let's look at x cubed plus 25y cubed. Again, these are all perfect cubes. X cubed, y cubed, perfect cubed. 125, that is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So now that I recognize what's A and what's B, I just need to fill in the blanks. And this one's a little, let me zoom in on this one. Some students freak out about this part. I encourage you to just, in your first step, to just do this. Put it in and put them in with parentheses. So x plus 5y, I don't really need the parentheses with that, there's no multiplication. X squared, so x squared. And then A is x and B is 5y, so I'm just going to write x times 5y. In my next line, I can rewrite that as 5xy. We like to write them in alphabetical order with the numbers in front. And then this is 5y with parentheses around it squared. This is 5y times 5y. So that's 5 times 5, which is 25, y times y, which is y squared. If you just wrote 5y squared, then you'd be done, but then you would not have filled out you would just have had 5y squared, not 25y squared. So make sure that you do that. All right. So next I have I have a little quick fire challenge. So I have 8x cubed minus 27, 36x squared minus 1, and 16x cubed plus 2y cubed. And here's my note that those don't factor. So what I want you to do is to factor those polynomials using those above formulas. I'm not going to tell you which is which. That's your job. You need to figure out and apply it. Remember to always check for GCF first. All right, pause the video. Try these 3 on your own. All right, let's look at the results of this quick-fire challenge. So are the 8x cubed minus 27, that cube's a little bit of a dead giveaway, that this is a difference of cubes. I know it's a difference because it's a minus. So I see this x cubed and I see a minus. I might not know right off the bat, but it's like, well, that's a pretty good shot that it's a difference of cubes. Now, on this lecture, it's pretty obvious that it is, but what you should do is then, if you're not familiar with your cubes, then just test those. Like, is 8, or actually first we know 8 and 27, there's no GCF, so I don't have to worry about that. Is 8 a perfect cubed? Yep, 2 times 2 times 2. 2 cubed is 8. What about 27? That's 3. 3 times 3 is 9, times 3 is 27. So this is the difference of cubes. So I go through this process again. When I square the 2x, make sure to put in parentheses, and then multiply them together, and I get this time, instead of 2 different variables, I have 2x times 3, and 2 times 3 is 6. So I get that 6x. And again, this cannot be factored. I don't even have to try. It will not happen, so I'm not even going to bother with it. That's my final answer. All right. So then 36x squared minus 1. I see a square and I see a minus. Now I'm going to check. So I'm thinking to myself, I think this might be a difference of squares. Let me check the numbers. 36, yep, that's 6 squared. What about 1? Yep, 1 squared is 1, so 1's a perfect square. So then write this down just for my benefit so I know what my A and B is if I need it. So it's 6x plus 1, 6x minus 1. Order does matter. If you wrote 1 plus 6x, 1 minus 6x, that would be a problem because of this. Because this is a negative 1. So if you switch that and get a 1 minus 6x, that is not this. So do be careful about the order of these. And lastly, so again, I'm seeing cubes and a plus. So my brain's thinking, oh, is this the sum of 2 cubes? Well, what about 16 cubed? No, that's 2 to the 4th. That's not 2 cubed. And what about this 2? Oh, right. I got to do GCF first. There is a GCF of 2. All right, so you got to pull out this 2 here. And now look at this. So again, we have the same x cubed, y cubed. Cool. Now we have that 8. Is 8 a perfect cubed? Yep. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And then what about that 1? That 1 is a perfect cube. 1 times 1 times 1 is 1. So now we're good to go. This is not a required step, but this helps some people sometimes for you to see if just square rooting it and cube rooting it, if you don't like that over here, sometimes leaving like a little fill in the blank. So what was it before I filled it in? It's like I had 2 times, oops, let me write that again, 2 times what cubed plus what cubed. So it's like, what could I put in those blanks to make that be true? Well, if I put in a 2, that would give me the 8. If I put in an x, I would get the x cubed. So 2x parentheses cubed is 8x cubed. What could I go in this blank? A y. So you can sort of think of like fill in the blank, that fits your style more than just like basically cube rooting these things. All right, so then we fill it in. Again, 2x squared is 4x squared. And then 2x times y is 2xy. And there you have it. So that's our special cases. And I just realized my board note didn't change. The thing above me this whole time was the wrong one. Let me show you what it would be. Ta-da! I changed it. Just pretend that was there for this whole video. So this has been Leach with Simpson Math. Hopefully through all these videos we've been able to figure out how to factor. There's lots of practice waiting for you on your homework if you're my student. So go do the homework, practice lots, ask me questions, ask your classmates questions. You got this. This factoring is not going to go away. It's fundamental review. You're going to see this over and over and over in this course. So it is time for you to factor it if you're not already, it's time for you to master it if you are not already a factoring master. So take care, and I'll see you in the next set of videos.